Good, hello. Oops. Hello, I'm Jan Borch. I'm an IoT specialist solution architect working for AWS. And I'm covering and helping customers across EMEA with IoT workloads. So I'm specifically focusing on IoT workloads in the cloud. And what we've seen is since I'm 10 years in the cloud business, 4 or 5 years ago, we really saw an interest from manufacturing and industrial customers to combine OT technology with cloud technology. So since 5 years, I'm focusing on this one. And today, I will talk about kind of large-scale data delivery to the cloud using OPC UA PubSub. So why I took this topic, because a lot of customers come to me and the typical use cases they talk about is predictive quality, asset condition monitoring, predictive maintenance. And all of these use cases have something in common. They need a lot of data. And when I talk to my customers, what they often see is they need this data in a central place. Of course, as AWS customers, they choose the AWS cloud for doing the analytics, the kind of data cleansing, and all the data lake aspects. From this perspective, is we need an effective way to get data from different facilities, shop floors across the world into kind of the cloud environment. There are cost challenges in this one. A lot of the demos today were kind of application to application kind of demos between an application using a browser with PubSub to another application. The use case of cloud connectivity in the industrial space that I'm talking about is more kind of like massive amount of publisher from different location into a cloud environment, and then forwarding this data into some kind of analytic services in the cloud. And in this context, there are kind of key challenges we see with our customers. The first, of course, is the data access. I think here OPC UA and OPC PubSub is, in fact, one of the solutions our customer choose to get data from their machine, from their controller, from their field devices, into a format that they can upload to the cloud. Now, in data access, that's fine, but now we go to the next level. I think the challenge is then it's scaling from I think we had this discussion from a prototype into kind of a production system where you don't talk about one machine and a dashboard, but where we're talking about multiple machines, production sites, or worldwide kind of aspects. Even sometimes bandwidth is a problem. I work with one customer that had a production site in Pakistan. The bandwidth connectivity from their production site is very limited. So we need to also have an effective way to upload data into the cloud environment. And then we are talking, of course, about multiple kind of publishers, like maybe thousands of publishers. And all of this, of course, in a secure manner. We don't want to kind of leak data and things. So it needs to be securely end-to-end from the control OT network to the cloud. And then most of the time what I ask is, okay, what data do you need in the cloud to kind of realize your use cases? And most of the time, my customers, often I talk to IT and OT, they say like, we don't know yet. So there is this kind of business use case we need to do, but we don't know yet. So just send all the data up and at the highest granularity, everything we want. We will decide later on what we want to do with this data. Of course, this poses challenges. And just a small example here, if you send data once a second and you have 5,000 data points, this is 5 megabytes per second. It's 12 terabytes per month of data. If you talk to a database administrator, say like, give me a database that will grow by 12 terabytes per month, he will not be happy. So there's also these challenges about this. We need a solution where you can decide flexibly what data to send up, and maybe also dynamically change the behavior, the frequency, what do you want to set up on things. So in this context, and with these kind of challenges in mind, 2 years ago, one of my customers came to me and said, like, look, we looked at this OPC PubSub, do you know about it? I said, like, oh, I don't know about it. We want to use it for sending data into the cloud. Can we investigate together? I said, like, okay, cool. So I looked up the internet and found a process. hey, they have a Java library that can do this. So I contacted the uni, and he gave me an evaluation license, and I start kind of prototyping. To Stefan's things, I think the best way to kind of understand the technology is to prototype. So I started prototyping. In fact, I was very quickly able to connect a PubSub client publisher to IoT, and we published together an article like 1.5 years ago about the thing. It was really easy. But it doesn't address the scale aspect. So today I want to talk a bit about my learning experience, extending this prototype to also address some of these scaling aspects that our challenge had, from a data volume, bandwidth, but also from number of publisher and how to things. Very quick, that's the only slide I took from my marketing. This is AWS IoT Core. This is one of the services that we will use, is our managed IoT platform. I won't talk about all the different features we have on the right side, like the rule engine, the state management, device shadow. I will concentrate on identity, device, and message. In fact, this is the MQTT management broker that we use in the cloud that every customer gets when they open an AWS account. And identity is the security aspect, which is very relevant in your use case, because if we scale without security, it doesn't matter. So the key feature that are important to understand in context of OPC PubSub is AWS IoT Cloud supports first TLS 1.2 and 3. So we have encryption on transit using kind of standard encryption protocol. We support the X509 based authentication, so the same kind of authentication mechanism the OPC PubSub client server and also PubSub uses. So we can integrate easily with the existing kind of security mechanism of OPC PubSub, and I will show you later on. You can also bring your own CAs, your own certificates if you want, if you have your trusted chain. We also support a fine-grained access control down to MQTT topic level. This is important when you start kind of collecting data from multiple sites, maybe from in the kind of OPC Federation context, from directly from machines or from things. And we also have this kind of just-in-time provisioning. I think important in the context of the onboarding we heard before. Onboarding devices at scale is another challenge our customer have. So to scale their deployment of the cloud. The message side, so we support MQTT 3.0 and MQTT 5.0. 5.0, I will talk later on, have some interesting kind of features that are very useful in this context. You can customize your MQTT topic space. We support retained messages, another important feature I will talk about later. Of course, binary payload. We can use OADP and JSON. And the most important one, this which in fact will influence the architecture I showed today, it scales automatically with usage. In fact, when you open an AWS account and you get your broker, by default you get 500,000 simultaneous connections. Out of the box, every customer that opens an account. And if you need more, you just need to open a single request. And we have customers with millions of concurrent connections. This has implication on the architecture we'll show you later on. For security-related aspects, the internet, sending stuff over the internet might be scary for some customers. We also support going over private network, direct connect it's called, VPN, or other private technology. So, let's head back. So I started my prototype. The first thing we will start is the publisher. So the publisher sits on in your OT network. It's getting data from OPC UA and it's sending the data up to the cloud to my AWS IoT core broker. As defined by UNI, on the first object we need to instantiate or configure is the connection. And here it's quite easy. In fact, you just point it to the endpoint, to your MQTT endpoint in the cloud. You can use the same device certificate, self-signed or provisioned by your OPC Discovery server, because we use also X509. You just need to register the certificate, of course, in the cloud so that you have an access. You have specified some TLS settings. You choose your MQTT transport type, and then you choose your encoding. So this is the first step of my prototype. It looks like this. I have on your industrial side one OPC PubSub publisher, an agent that is running somewhere on an edge machine, on a virtual VM or whatever on site, taking data from various different kind of OPC server and sending it up to the cloud. Now, this works well, but imagine that we have like thousands of these OPC sources. having a single kind of publisher process that takes this data and pushes it up might not be the most scalable way of doing it. Also, every time you're changing, in fact, new data source on the right side, you need to change the configuration of this publisher. So I think with also in mind that AWS IoT scales on the number of connections to 500,000 or what you want. So you don't need to do anything on this side to provision scalability. So this opens up really new ways of ingesting data from your shop floor into the cloud, into the AWS cloud. You could have, in fact, like hundreds of individual publisher that take individual data, securely connecting with their identity to AWS and sending everything up to the cloud. It has some advantages because from a high availability perspective, if one of these PubSub dies or things, it's not a big deal, in fact. You still have all the other ones that are running. It also, from a scalability perspective, but the single connection is a limited number of data blowing up, but you scale horizontally. So it's more kind of a distributed architecture. Now, you might see like, okay, but in my network architecture, with my layers, I will never be able to connect from my OT network into the cloud. I agree. This is one of the discussions we have with a lot of customers. I think, and that's my kind of vision of the future, if you look at the kind of zero trust kind of trend that we see, especially in enterprise network at the moment, where we go from a security model where the security is based by location inside the network to a model where the source or the network devices uses a strong identity, for example, XO59 identification, a strong authentication authorization mechanism, and encryption. I think these kind of zero trust standard will also kind of change the way industrial network will evolve over time. But that's of course forward looking, and so. We have now our things, we have like multiple publishers, and as you said, we can scale these publishers to 500,000 with your default AWS account. The next level is the writer group. On the writer group, you specify, in fact, what you want to send over the wire. There are two kind of attributes that are quite interesting in our use case, is the publishing and the network messaging size. These two things are quite important because you want to maybe limit the number of data that is sent by a certain publisher. Or you want to maybe kind of limit it for a certain period of time. Okay. You want to maybe limit it because, in fact, the data is not needed and you just send it every 5 minutes. But when you do a diagnostic on your device, you want to maybe increase it. So by changing configuration of these things, you can adapt a single publisher interval, but you can also limit the bandwidth used. As I said, my customer there has some limited bandwidth on the things. He cannot consume all the data to send IoT data up to the cloud. He also needs this network for other means, for internal uses. So, and just a small example based on my prototype. In my prototype, I created a small OPC UA server that has 100 measurements that are changing every second. I created my small PubSub things. If you use the JSON payload, we have 8.6 kilobyte of data. If I use UDP, the binary format, we go minus 57%. We have 218, like 2K, which is kind of a big kind of consumption, because all the metadata is not sent to the normal payload. Of course, you can adapt the publishing interval, and there's another cool feature in OPC PubSub. It's called keyframe count. If values don't change every second, you can only send the values that changed and specify in how many frames you want to send the whole set again. So using binary payload is quite useful and to in fact limit the bandwidth that you are using for sending data up to the cloud. Then the last thing is the dataset writer. There you specify, in fact, to which topic you want to send your data, but also which of the OPC nodes you want to, and variables and events you want to things. So that's how my things look like. I choose, as you said, as in OPC, you can choose whatever. I choose an MQTT topic structure where I specify the worker group ID and the dataset IDs and the writer ID to be able, so that every publisher sends to a specific data topic and to a specific metadata topic. You can, of course, have the same publisher with the same writer having multiple data sets. You're flexible on this side. Now, the interesting part of PubSub is the metadata aspect. So this is a view of AWS IoT, the console view, but you can also access this to API, that shows you the retained messages, because metadata are sent to specific topic with a flag called retained. So it will be stored persistently on the AWS IoT side or on the broker side. And it contains, on here, it contains, in fact, the metadata description of the binary payload that you need, in fact, your subscriber needs to decode your data. Now, it's not only for getting metadata, it's also interesting because, in fact, you can browse, in fact, all the publisher by accessing, in fact, the metadata catalog. So let's move, I think I have 5 minutes, let's move to the other side. Okay, now we have 500 public subscribers sending data to IoT to different kind of message structure. We talk about the connectivity use case, so we want to push this data into some kind of databases, data analytic data lakes to do kind of predictive maintenance, analysis, reporting, and understanding the state of your machines. On the publisher side, on the subscriber side, exactly the same. Pub connection settings are the same. Reader group is just an ID. But we just have to point it to the right topic so we can get the data, but also can read the metadata so this publisher understands how to decode the binary payload. And here we can, so this is the kind of end-to-end architecture I created for my prototype. I have one subscriber that can run in a container environment, on an EC2 instances, or wherever you want in the cloud. But interestingly, on the top right corner, you don't have to pre-configure all your dataset readers, as we've shown in various different demos, because the subscriber can discover them automatically. AWS IoT, for example, you can do this over API. It has an API called setGetRetainedMessages. It will give you a list of all the retained messages that are published by subscriber to the AWS IoT core. It can read the metadata, configure the subscriber to use this. And in this case, can also then dynamically, in fact, create all the dataset reader to read the data down to the. Now, this from a scalability perspective, there is one problem. We have one subscriber here, one process running in a container that is going to all this data. Imagine having thousands or 5,000 publisher here, like if we, as you've seen in the OPC stack, OPC is going down to the field level, to controller level. Why not having control and field level things directly sending MQTT PubSub data to the cloud? You have like maybe thousands of here, but we only want kind of have one subscriber, because the idea of the subscriber is to push it down to any data analytic, data lakes, or databases. So what you can do, you could have like multiple subscribing to a subset of the data. Another option, and this is something we would have to talk, is the new MQTT 5 specification has a concept of shared subscription, where you can have a subscriber that subscribes to a topic, or multiple one to the same topic, and in fact the IoT core broker will distribute the messages to different kind of subscriber in a round-robin way. So this is a way, in fact, to scale your subscriber by using shared subscription. Then the other kind of native way, if things is in fact, let's say like we have PubSub on one side, we have the metadata published to IoT core into retained messages. We can use one feature of AWS IoT, which is called the rule engine. In the rule engine, I would just say, give me all my messages across all publisher, across all writing groups, and across all writers, and publish it down to what we call an action framework. Now, there is one step we need, because this message are binary encoded in UADP, and our backend service or databases might need a JSON encoded format. So what you can do there, you can do an on-fly kind of decoding using a UADP decoder that will read the retained messages, understand the metadata format, decode the format, and sends a decoded format in whatever format to your backend application in the cloud. In my demo, I use AWS Sidewise for this. As I think AWS Sidewise is an industrial kind of industrial kind of product service at AWS IoT that is a time series optimized database for industrial equipment data. It adds also a real-time analytic engine on top, so you can do kind of correlation of data. And it also has a dashboarding application. But of course, it doesn't understand UIDP. or binary format. So with this kind of small rule engine implementation, we can forward the code and forward the data to whatever service you have on the side. And if you use AWS IoT, this is the AWS IoT Sitewise console. When data comes in that is not mapped to a kind of a project, it comes into the data stream section, and here we'll see the measurement coming up, and we can look at the data, and then later create dashboards out of it, assign it to modeling data, or further along. So this was a small presentation of how you can use cloud features, cloud technology, and OPC UA PubSub to build a scalable architecture to get data into your cloud for typical industrial use cases.